So this is the a graphical representation, a schematic representation of the three-port operation. So in a CISO battery mode, single battery is providing power to the load. Single input dual output. The converter behaves as a SEPIC converter. SEPIC converter here, it will store the energy. Inductor L1 will store the energy, and stores energy will be transferred to the load in the when the switch S1 will be off. Okay, so this is the CISO mode, and then single input dual output. This is the mode when both single input means the PV is generating more power than load. So here we can see first switch S1 will turn on, and it will store the inductor L1 will store the energy, and when switch S1 will be off, the stored energy will be to supply power to the battery. When both the switch S2 will be off, then stored energy will transfer its stored energy of inductor L1 will transfer it to the output. Then I will come to the DSO dual input and single output. So in this mode, as we PPV, as already we have discussed, the PPV is generated power by solar is less than the P load. So battery and both battery and solar PV both provides power to the load. So this is the experimental setup of the this work with the TMS 320 F28335 microcontroller. Now I will come to the its result, and it is somewhat interesting. We can see from the result, we can understand how the whole system is working. So you can see this is the reference power. This is this line we just see. This is the reference power. When reference power means the load reference power. So a battery and battery and PV is used to supply the uh, load power, as we will see all the mode which we have discussed. So initially uh, solar PV, this is the irradiance variations. Irradiance, zero irradiance means there is no solar PV variations, solar PV power generation. So initially solar, and this you can see uh, this is the reference power, and this is the solar uh, solar power, which is reference solar power. Okay, and this is the generated solar power. So initially there is no solar PV generation. So to provide the power to the load, battery will discharge, so SOC of the battery will decrease. And again here we can see here the solar PV is generating the power. Okay, solar PV is generating the power, but it is not generating the required amount of power to satisfy the load. So battery again will discharge to supply power to the load. Okay, so here this in this section we here load power and generated power both are same, so battery will not charge or discharge, so its SOC is constant. So again here we can see the generated power is higher than the load power. This is the load power line. So battery will what the solar PV will supply the load power as well as charge the battery. So SOC of the battery will increase. So again, and this here when battery will charge, at this in this region. So battery will be if battery is at this point, battery is fully charged, so solar cannot and the load power is less than the load power is less than the generated power, so there will be no maximum power point tracking operation be will take place. So this is the a hardware results of this work, how the battery discharging will take place from whenever battery will discharging take place, its current will rising. This is the transient, only transient waveform has been shown here. And input and out input voltage and output input voltage means that solar PV input voltage, and output voltage means the output load voltage. Output load voltage is usually constant in nature, and the input voltage solar PV voltage will change according to the solar irradiance. So this is another kind of a propulsion and charging system for the electric vehicle. So here we can see a ultra capacitor and battery is used to supply power to the load with with a developed control strategy. So this these two source which is connected by the isolated isolated cup converter. So it is isolated using isolated cup converter. Here you can see uh, super capacitor and battery. So this is the reference power which is demanded by the load, and super and the try to understand its control strategy from the here a lookup table is made for the super capacitor. So super capacitor will have stored energy. So if reference power is not made by the super capacitor, so rest of the power is supplied by the battery. This is the PV reference. This one is the PV reference. So PV reference, battery reference power, as a battery will provide power only when supercapacitor is not having sufficient power to supply to all the load demand. So here switches S1 and S2 is used for the PWM operation during the propulsion operation, and during the regenerative braking operation here we use to charge the supercapacitor. So detail logic is shown in this flow chart. When and supercapacitor will supply power when its terminal voltage must be higher than the its threshold terminal voltage, because as if the terminal voltage is very low, it may possible that supercapacitor can provide a very high amount of power. Still, it can provide power, but it will draw a large current. In such situation, there will be high losses in the supercapacitor as well as the in a converter system also for at a high current. So we will take care about it will supply power at when its terminal voltage must be higher than the threshold voltage. And during regenerative braking operation, supercapacitor terminal if it is fully charged, terminal voltage less than the its VSC max, whatever its maximum voltage. So in till that it will be charged. In regenerative braking, many work is going on that we people are avoiding to charge the battery during the regenerative braking operation, because battery frequent charging and discharging of battery leads its life will sacrifice. So supercapacitor or ultra capacitor we is used to recover the regenerative braking energy. So it's a mode of operation shown here. Uh, when supercapacitor is alone providing power, it works as a isolated isolated Cuck converter, and in all the mode it works as a isolated Cuck converters only. Whether it is both supercapacitor and battery are providing power to the load system, when battery alone is providing power to the load, and when supercapacitor is providing power when this is the regenerative braking operation. Here regenerative braking operation will take place for charging of the supercapacitor. So this work is implemented through the Opel RT4512 real-time simulator, which is shown here. So we from the results we can understand how the complete operation is going on. So uh, as at this in mode 1 you can see from the diagram, in mode 1 only supercapacitor is providing power, so battery current is 0 here. So at supercapacitor terminal voltage is going down. This is the supercapacitor terminal. So and its power supplying capability is also decreasing. So battery is providing power. At one point here, when supercapacitor is completely exhausted, then in that situation, battery is alone providing power to the load system. So this is the propulsion operation. This is the regenerative braking operation. In this here, supercapacitor is used. Supercapacitor is being used to charge the system. Okay, so its terminal voltage is increasing slowly because it is the operation for the charging. Okay, so the work which is shown earlier, with that was based upon the isolated Cuck converter. Again, this work is implemented through the non-isolated converter, as the logic is the same. Only there are some advantage which came using the mm, through the non-isolated CPIC converter. So operation is a very well known, as I will not go in detail of the operation of the converter, but I will come to the again the result part of it. So you can see here in mode 1, it is the supercapacitor, and this is the supercapacitor power, this is the battery power, and this is the supercapacitor terminal voltage, this is the battery voltage, and this is the DC link voltage. So uh, as long as the supercapacitor alone is providing power, so battery power will be 0, and as when its power supplying capability will decrease, so battery will supply power to the system. This is the inductor current IL1 and IL2 and IL naught, and it is inductor currents are in triangular nature. Okay, which shows the effectiveness of the system. It is natural waveform of the inductor in a DC to DC converter. So in a regenerative braking operation, both in this particular system, both uh, uh, battery and supercapacitor used to charge by the regenerative braking energy. So till this point, battery voltage is constant. Only supercapacitor, first supercapacitor terminal voltage is going up. So it is being charged by the regenerative energy. After that, battery voltage is start increasing, and supercapacitor, because it has a fully charged. So this is that it's a real-time implementation diagram. Whatever I have shown the simulated, exactly same is mimicked here with the lower ratings. So now I will another efficiency and loss analysis of this converter has been done in a Matlab through the analytical calculation. So interesting things we can see here. The losses, if there three inductors are there, three inductors are there. So inductor we can see the highest contributor in the total losses around in different modes of operation: battery discharging, supercapacitor discharging, and combined battery and supercapacitor discharging. So around 56, 58, and 60% are losses are contributed by the inductor, because the inductor is the has a high equivalent series resistance. It's our parasitic resistance. So the design of inductor we should have take care about, so that the losses can be minimized. Means we quality copper material and its core losses must be minimum, because in this not only copper loss of inductor is there, its core loss is also there. So now I will come to the another kind of a multi-port system. Here I am going to discuss the multi-port system. What I have earlier told, that a multi-port system is very popular because of that a single converter you can achieve various modes of operation like charging, propulsion, and regenerative braking. So you can see a solar PV and grid-based charging system. Here battery is there, port one at a grid, port one at a rectified. Uh, and solar PV both are connected rectifier, and there is another port where battery, and third port is the DC link. So both, but in this mode of operation, solar PV and grid are operating not operating in a complementary fashion, not in a simultaneously, because 2 points here are connected at same means these solar PV, if this can solar PV and grid at connected same points, so its voltage are not same also, rectified voltage, so they cannot operate simultaneously. So control strategy is very simple. Whatever is the here solar PV, if solar PV is used, it will MPPT operation will take place, and the switch S1 will be operated through the PWM. And if solar PV is not available, then grid is used to charge the battery, and this convert work as a isolated SEPIC. It works as a isolated SEPIC. So you can see here. Uh, Only grid is it is the rectified voltage. I am directly written remove the diode part. On after the rectification, this converter behaves as the isolated epic to charge the battery. And in this here solar PV, when grid is not there, so solar PV is used to charge the battery. So in a propulsion operation, this converter behaves as a flyback converter. So in a flyback converter, this is the uh, transformer. Switch S2 will be operated in a PWM, and it will supply the battery will supply power to the DC link, and DC link will supply power to the motor drive system through the DC to AC converter system. In a regenerative braking operation, when battery will be charged by the regenerated energy. Okay, so again it behaves as a flyback converter. So now I will come to its result part. So here grid voltage is taken as 220 volt, and the charging power is 1.2 kilowatt. So you can see here while charging one of the objectives to maintain the grid voltage and grid current sinusoidal in shape. and as well as in phase with each other. And battery current, which have a second harmonic component, is there in a battery current. So it will be inherent in the system because of the uh, single stage operation. In a single phase single stage operation, second harmonic will come, and it will can suppressed by some control strategy as well as or some filter component. So this is its hardware implementation part and its hardware results there. So this is the MPPT at 1000 solar irradiance. Solar PV is generating 800 watt at 500 solar irradiance. It is generating a 400 watt power. So this is the hardware implementation of this work. Here 48 for 12 volt batteries used, and others are through the D space 1104 controller, and these are the switches. The resistive load is used to implement the propulsion operation. So we can see here in a propulsion mode of operation, when battery is providing power to the load power is changed from 1 to 2 kilowatt. Our objective is to maintain the DC link voltage constant. So from the control strategy, we can say DC link voltage is a constant, kept constant as the variation of the load power, 1 to 2 kilowatt, here 2 to 1 kilowatt, and 1 to 2 kilowatt. So DC link voltage maintained at a constant, but its hardware part is implemented with lower rating. Power is varied, load power is varies from 400 to 500 watt, and DC link voltage is here only 150 volt. So it is a regenerative braking operation. In a regenerative braking operation, uh, uh, here DC link voltage is increasing by the regenerated energy, and battery is charged at a constant current of 3.5 ampere. So again, this is another integrated type multi-port converter, where solar PV is connected through the converter. In previous work, it is connected at here at output of the rectifier. So where it means whether either solar PV will can provide power to the battery, or a grid can provide power, but both cannot provide power simultaneously. So in this work, solar PV is connected to a different converter. Both are supplying power to the load or battery simultaneously. So because here we can see this converter work as a MPPT converter. Okay, so it works as a MPPT converter. Here P reference, P reference is the total reference power which is used to charge the battery. If and this is the power. PPV power means solar PV power generated. So reference solar PV power is reference power is subtracted. Uh, uh, Solar PV power is subtracted from the reference power, and this will generate the power which is drawn from the grid. So grid is here is a secondary use if the solar MPPT is sufficient. Solar is sufficient to supply power to the battery. So grid will not use to provide power to the battery. because we are assuming that in grid there power is stored in power is there, but it is from the fossil fuel base. So this is the converter operation. Converter operation is simple, and here it operates as an isolated septic. It is in this mode when solar PV is providing power, then it is operates as a non-isolated septic. When both are operating simultaneously, combined operation. When solar PV and grid both used simultaneously to provide power to the battery. In a propulsion mode, one interesting thing is that a battery is used to supply power to the load through boost operation. And boost operation we prefer in the system because it provides uh, it will has a lower stress on the passive component as well as on the semiconductor devices compared to the SEPIC operation. In a regenerative braking, switch SA2 will be in a PWM. A converter works operates as a buck converter. It works as a buck converter uh, to recover the regenerated energy. Now I will come its result part. Its result part only I have shown its hardware part, and again voltage and current are in same phase with sinusoidal shape. It is also a single stage and single phase charging system, so there will be a low harmonics in the battery current will be there. Total harmonic distortion is around 4.4%. So here it is shown, switch voltage are shown here. So in the zoomed form. Now this is the propulsion operation. So in propulsion operation again, load power is varies. Whenever the load power will vary, the battery will supply more power. Okay, battery will supply more power, and we are keeping the DC link voltage constant. This is the DC link voltage. So in a regenerative braking operation, here a regenerative braking operation is there. Battery is charged with the uh, a 10 amperes of current, and DC link voltage is decreases as well as the regenerative braking energy exhausted. So now I will come to another multi-port converter system where fuel cell battery and ultra capacitors are there. So you can see this is here a ultra capacitor is connected. This is the battery. This is the fuel cell, and this is the DC link system. So our in the beginning of the lecture we have seen that a multi-port converter system is useful because it requires a single converter to incorporate all the energy sources. Okay, so it will not only reduce the cost of the system as well as overall charging and propulsion system weight and space. Weight is as well as it will not contribute weight much, but always the space is another important thing when we come to the vehicle. So space is a important parameters. So in a different modes of operation, the converters will work, and here boost operation will take place from the ultra capacitor when switch S1 will be turned on uh, permanently, and switch S5 and 6 are PWM operated. boost operation, ultra capacitor and fuel cell. As a fuel cell, uh, this switch S6 will be in a PWM operated. Uh, so it will supply inductor L3 will store the energy, and through the body diode of switch S5 and S4, it will supply to the energy to the load. So similarly, the battery boost operation will take place from the battery also. We can see here switches, uh, here switch S5 and S6 will be turned on through the PWM operation, and S2 will be permanently turned on. So it will store the inductor L2 will store the energy, and and again inductor L1 and L2 both will store the energy. And when these switch S5 and S6 will work, through the body diode of switch S4, it will supply power to the load. So in a regenerative braking operation, DC link will supply power to the from the DC link, whether it will supply power to the ultra capacitor first or super capacitor, then after to the battery if there is a provision of a battery charge. So this is another single input dual output multi-port converter system where DC grid or some DC source will be there. Here battery will be there. This the solar PV voltage will be there. So there are lot of works in a multi-port converter system for the electric vehicle to incorporate the all the energy sources. So now I will discuss one work related to the whatever I have shown the charging system till it is based upon the single phase charging system. So now I will discuss one work with the three phase charging system, because the for high power charging or off-board charging application, three phase supply is used to charge the battery. So this is a three-phase charging arrangement. There is the front-end converter, or it is known as the interfacing converter. Second stage is the interleaved buck converter is there, and it is the modes of operation for the buck interleaved converter is shown here. So as we know that in interleaving techniques, switch S7 and S9 and S11 are 120 degree out of will be 120 degree out of phase, means the sequence of turn on will be has a phase shift of 120 degree. So it is a control strategy of three phase AC DC converter. So it is very well known control strategy which is developed in a DQ reference frame. Uh, Here VDC, we are controlling the DC link voltage. So DC link voltage generate a direct axis reference current, and the quadrature axis current kept zero uh, for for the uh, so that grid cannot absorb uh, the reactive power. For that purpose, IQ reference will be 0. So this VD and the ID reference and ID measure direct axis current measure, it will generate VD control and similarly VQ control, and it will convert it into VAVC reference, and VAVC reference is compared to the carrier signal that will generate a PWM signal for the switch S1 to S6. S6 means these front end converters switches. So in the control strategy of the three phase DC-DC converter, three phase interleave here as we S7, S9, and S11, I think. This was the sequence. Yes. So switches has two establish the 120-degree phase shift. So here carrier signal is delayed 120 degree with respect to the first carrier signal, and with respect to first it is 240 degree. So these PWM signal will supply to the switches. So this is the result part. Here we can say load power or charging power is changed from 3.3 kilowatt to 4 kilowatt, and battery current, you can see battery current is varied from uh, around 30 ampere to 38 ampere, and this is the grid voltage and grid current, three phase grid voltage, three phase grid current are there. They are sinusoidal in shape. This is the one of the main requirement while charging, so maintaining the unity power factor operation at a grid site. So the inductor current, which is 120, these three inductors current, I am talking about these three inductors current. These three inductors current, they are 120-degree out of phase. And overall output current ripple, we can see that this is the ripple in the output current. So interleaving techniques reduces the ripple in the output current. If there will be reduction in ripple current,